All right, this is section 7.1. We've just finished chapter 5, which was on adding and subtracting polynomials. And as we get into chapter 7, this 7.1 actually is all about multiplying and dividing monomials. So if we did this chapter first, you would have no idea what monomials were, but so that's why we did the chapter on polynomials first. And now we have an understanding of what monomials are. Here's a monomial, and it's being multiplied by another monomial. And for this particular one, this chapter 7.1 is going to ask you to be able to represent that in two different ways. So I'm going to just change this real quick to another variable x. I don't want to use y right now. I'm just going to use x. And I'm going to make this 4x multiplied by 2x. Now the first way we can do it, now remember 4x really means 4 multiplied by an x value. So 4 is a coefficient, x is a variable. Whatever that x value is, if it was 3, for example, this would actually be 4 times 3, which would mean the 4x would have a value of 12. But algebraically speaking, we don't have to think of it in terms of what the value of x is, just that we know that it means 4 times x. So what this means is if I think of this question, and I'm going to erase this one for a second, it's 4x times 2x instead of 2y. What this really says is 4 multiplied by x multiplied by 2 multiplied by x. Okay? 4 multiplied by x multiplied by 2 multiplied by x. And what we need to understand is that the associative property of mathematics states that if you have multiplication, let's just say 2 times 3 times 4, or since I'm using the dots, I'm going to go 2 times 3 times 4. If we have those three numbers being multiplied together, the answer here is 24. But according to the associative property of mathematics, the order in which I multiply those terms, I can go 3 times 4 times 2, and I'm still going to get 24. Or I can go 4 times 2 times 3, but I'm still going to get 24. So when you have a multiplication string of numbers, the order in which you multiply does not change its value. That's what the associative property of mathematics states. So using that idea here in this monomial times monomial, since 4x times 2x means 4 times x times 2 times x, I can rearrange them to multiply my coefficients first and my variables second, and it's not going to affect the product. And therefore, since 4 times 2 is 8, and x times x is x squared, the product of 4x and 2x using the associative property will be 8x squared. That's one way of the two different ways to solve it. A second way we can solve that is using modeling. And since a monomial times a monomial, we like to use area of rectangles to be able to solve that. So if I think of a rectangle, and I was to say the length is 5 and the width is 2, if I multiply 5 by 2, I get the area inside here, which is 10. So 5 times 2 gives us an area of 10. So we would write it like this. We do a rectangle, we go 5 and 2, and the area equals 10. That's numerically when we're talking about grade 4 or 5 work, when we learn how to multiply two numbers together to get the area. When we take that idea and work it over into monomials or algebraic monomials, if I think of the length as being 4x, and I'll make that into these x tiles. Remember, that's an x tile. Remember, we talked about that shaded in being x tiles. If we make that into an x length, that's 1x, that's 2x, that's 3x, that's 4x. This length now has a length in terms of my rectangle of 4x, and my width can be 1x and 2x. So if I think of this as being this rectangle here, 4x and 2x, this black rectangle I can now draw here would be the area inside there is going to be the product of those two. So what we do now is we simply connect those two there and connect these down like this. And now I can see that inside there I can see the area. And this particular square right here has a length of x and a width of x. And we learned in our chapter on exponents that x times x equals x squared, a positive x squared. So therefore, I better shade these in green here just 1 second. Those are all positives because a positive times a positive is a positive. And therefore, the interior of that rectangle whose length is 4x and its width is 2x, has an area of 8x squared, or 4x times 2x equals the area of 8x squared. The length multiplied by the width equals the area. Okay, so therefore that's another way to prove that 4x times 2x is 8x squared. If I think of the second question, solving it two different ways, negative x multiplied by 7x, if I use the associative property, I could think of this, actually negative x has a coefficient of negative 1. It's negative 1 times x, that's negative x. If I use my highlighter here, negative x is really negative 1 times x, multiplied by 7 multiplied by x, which is our second term. And therefore, negative 1 times x times 7x, if I rearrange those using the associative property, I end up with this, or negative 7x times x is x squared. So my solution, using the associative property of mathematics, is negative 7x squared. If I model it, and I'm thinking about this being the length and this being the width, the area will be the product of those two. I'm going to make this my negative x. Okay, so I'm not going to shade it in because it's negative. And my width is going to be 4, 5, 6, 7. Forgive me for the inconsistent sizes there, but you get the idea. Now, if this red rectangle represented the product of 7x and negative x, we would see that the interior, or the area, equals, this is going to be a positive times a negative, which means these are all negative x squareds, because the product of a positive and a negative is a negative. So therefore, the product using modeling is also negative 7x squared.